Hey there everyone, Lee here. Welcome to part 3 of my Santa platformer tutorial. In the last video, we left off with our character having two abilities, a dash and a butt slam, that is capable of destroying some platforms. In today's video, we're going to take a step back from code and we're going to implement some assets and take a look at Unity's animation system. And if you'd like to follow along, you can download the assets posted in the link below. And if you haven't done so already, be sure to check out the first 2 videos of this 6-video series. And with that, on to part 3.
To start off, we will drag and drop the downloaded assets right into Unity. There's quite a bit of assets. But for this video, we will just focus on the Santa folder. If we want to use a sprite, we can simply drag and drop the asset into our scene, but we will quickly notice that it is much too big. To fix this, we must click on the image and adjust the pixel per unit.
Pixels per unit is a way that Unity scales its 2D art. By default, Unity sets it as 100 pixels per unit. That means if you have an image that is 100 pixels wide, in the game it's only 1 unit. For our game, we want to make sure that our sprite remains 1 unit wide, but our Santa sprite is much bigger than 100 pixels. So we're going to have to change the pixels per unit to make it scale properly.
For the Santa sprites, we'll set it to 300 pixels per unit. Click away from the inspector and apply the changes. Now, when we drag the image into the game, it's the perfect size. Let's select the rest of the sprites and make the change there as well. Next, we will create a new folder called Animations, just to keep everything organized. Now, we will make some animations. Since the walk animation has the most frames, and everything is just 1 frame, we'll start with a walk. First, let's select all the walk frames in order, then drag them into the scene. This will create the animation automatically. Let's save it in the animations folder, and we'll call it Santa-walk. A game object with the animation is now in our scene. Now let's copy some components from the player game object into the new game object. In player, we'll click on the 3 dots on the right of our character controller script and select Copy Component. In the new game object, we'll click on any of the buttons with the 3 dots and select Paste Component as New. And then we'll do the same for the Capsule Collider 2D, and then the Rigid Body 2D. Now we can delete the old player object, since we no longer need this. When we hit play, we can move our new animation around, but you'll notice that it always walks and always faces the right. We'll fix these issues as we go along. In our animations folder, you'll see 2 files. The one with the squares is an animation controller, and the one with the triangle is the animation itself, which we will add more of. Let's rename the controller to Santa Animations. Next, we'll create a new animation and call it Santa Idle. And then we'll create some more for Santa Jump, Santa Dash, and Santa Slam. We will need the animator window to add these to our controller. So let's go to Window, Animation, Animator. We can see the animator by clicking on the Santa game object. We can use the mouse wheel to zoom, and we can use the wheel button to move around. Now let's drag and drop the newly created animations into the animator. Next, we will edit each animation. To do this, we'll need the animation window, which can be found in Window, Animation, Animation. If the window is floating around, we can drag the tap to wherever suits you best. Let's go back to the scene and click on our Santa object. We will see a timeline of our walk animation. To look at other animations in the controller, we can click on the drop-down in the animation window. Let's edit idle. To start animating, we hit the record button. In the inspector, under sprite renderer, we'll change the sprite to the idle sprite. And it will automatically add it to the timeline. Let's edit dash. Hit record, change the sprite, and then we do the same for the rest with the respective sprites. Back in the animator, let's change the default state from walk to idle. Right-click on the idle animation and click Set to Layer Default State. This ensures that idle is the first thing that plays. Next, let's create parameters for the transitions.
When we're creating animations, we want to give conditions to transition between different animations. In our case, if our player is walking, we want to walk. But if it isn't walking, we want to stay in the idle state. If the conditions aren't set, then the animator will play animations that we don't want. We can set conditions using parameters, which are just variables for the animation controller.
For our animation, we'll use an integer called state. Depending on that value, the animation will change. We'll use 0 for idle, 1 for walk, 2 for jump, 3 for dash, and 4 for slam. I'll arrange it in the animator so it's easier to manage. For the transition, we can right-click on an animation, click Make Transition, then click on the animation you want to transition to. This is one directional, so we have to make another transition from the walk to idle. Otherwise, the walk will keep playing. For the conditions, we can click on the transition arrow and look for conditions in our inspector. There's currently nothing, so click on the plus button to add one. And since we have no other parameters, it will automatically choose our state parameter. Because we are transitioning to our walk, state needs to be equal to 1. We also want the transition to be seamless, so we will need to uncheck has exit time and also uncheck fixed duration. For the other direction, we'll do the same. But since we are transitioning to idle, state will be equal to 0. In our controller, since every animation must be able to transition to every other animation, we must make everything transition to and from each other. It's a bit tedious, so I'll speed this up. Now that we have made our transitions and attached all the proper conditions, we need to write a bit of code to change the state parameter. First, we need to grab the animator in our game object. We'll store it in a variable called _animator. In the start function, we will assign it with getComponentAnimator. Let's make a function that will automatically change the state inside the animator. We'll call it updateAnimation. First, we'll focus on the direction of the sprite from earlier, which is simply based on the current direction variable used from the last video. Then, we'll change the states based on the conditions of the player from the booleans in the actions. For the direction, we'll simply change the scale with transform.localScale equals new vector 2, current direction 1. This will change the x scale to 1 or -1 based on our input. Next, I'll first list out the states to remind myself of the values. 0 for idle, 1 for walking, 2 for jumping, 3 for dashing, and 4 for slamming. Let's create a variable int state and have it 0 to start. From here, I'll use the available booleans I've created to set each state. First, for the slamming. Dashing. If neither of these are happening and we aren't on the ground, then we must be jumping. If we are on the ground and the horizontal tilt isn't 0, then we must be walking. And if none of these are true, we stay in idle. To set it in the animator, we'll use _animator.setInteger, in quotes, state, which refers to the name of the parameter in our animator, and our state variable we just created. Finally, we'll call this function in our update to ensure that the transitions are smooth and seamless. When we hit play, we can see our walk, jump. The dash and slam happen quite quickly, so let's slow these speeds down for now to see. The movement is slow, but we can see our animations works just fine.
And with that, we have created new animations using Unity's animation system, as well as used a bit of code to change the states of animation. If you have any questions or comments, feel free to leave it in the comments below. And if you're enjoying the videos, be sure to hit that like and subscribe button. This is a new channel, so any support would be greatly appreciated. And that's it for this video. I'll see you in the next one.